Okay, hello everyone. This is problem number 6 of the free Machine Design and Materials exam that can be found at engineeringappliedpractice.com. So let's start with the problem statement. Bearing hubs are produced at a manufacturing facility. A statistical analysis was performed on the hubs. 5 sample sets were collected, with each set containing 10 hubs. The range values shown in the table below. What are the upper and lower limit lines for the range? So if we look at the table, we can see that we have 3 sets of data, R1, R2 through R5, with a value given for each range set. So there's 5 sample sets. Each set has 10 hubs. So if we go and look at our reference material, there's a few things that we need to figure out. And I suppose if we start with what the question is asking, it wants to know what the upper and lower limit lines are for the range. So if we look at the reference material, we'll find that upper limit line is equal to D4 R bar, and lower limit line is equal to D3 R bar. So both of them have this R bar term, something that we're going to have to calculate based off of the data provided. And the D3 and D4 values are simply something that you can look up based on how many items are in a sample set. So in this case, there's 10. So for a sample size of 10 in each set, D3 is equal to 0.22 and D4 is equal to 1.78. Okay, so we have that. So, okay, what's next? We need to find the R bar value, where R bar is defined as the summation from I equals 1 to 5 in this case, because there's 5 sample sets, and it's equal to the individual value given here divided by 5. So you're sort of getting the average value for these sets. So that's going to give you 0.01 plus 0.005 plus 0.006 plus 0.008 plus 0.012. And again, that's all of these values. And then all of this divided by 5. So hopefully that's making sense. That's going to give you an R bar value of 8.2 times 10 to the negative 3. So now we have all the necessary information here, and we can simply plug everything in. So the upper limit line is equal to D4 R bar, so 1.78 times 8.2 times 10 to the negative 3, which gives a value of 0.0145, and the lower limit line is equal to 0.22 or D3 times R bar, which is going to be equal to 0.0018. Okay, so now looking at the answer selection, we can see that D is the correct choice. So that's it for this problem.